Hello everyone, welcome back to my YouTube channel. In today's video, I'll be teaching you how to balance simple chemical equation. Now, what is a chemical equation? A chemical equation is an expression that is used to describe a chemical reaction. A chemical reaction usually entails reactants reacting together to give us products. That is, we have the substances that are reacting together, which we have at the beginning of the reaction, known as the reactants, and then the substance that is being formed at the end of the reaction, and that is known as the products. Now, balancing chemical equation is based on the law of conservation of mass, and this law was given by Anthony Lavoisier. He's a Frenchman. This law states that matter is neither created nor destroyed in a chemical reaction. In other words, the total mass of the reactants should always be equal to the total mass of the product while balancing a chemical reaction. Now let's look at this equation that we have on the screen here. Here we have hydrogen molecule reacting with oxygen molecule to give us water molecule. Now take note, whenever you're balancing your chemical equation, the idea is that you should have the total number of atoms on the reactant side should be equal to the total number of atoms on the product side. Now, what do we mean by that? Looking at this now, we have hydrogen molecule here. Altogether here, we have 4 hydrogen molecule. How do I know that? 2 multiplied by 2 will give us 4. So if we count it together, we have 1, 2, 3, 4. So that's 4 hydrogen molecules. And they're coming to the product here. Also, now this big 2 that you have here is for all this molecule. It's for all these atoms that we have in this compound. In other words, this big 2 here is for both the hydrogen here and the oxygen here. Take note, you do not touch the subscripts. What do I mean by the subscript? The small number on the right-hand side of every species or of every particle in your equation. You don't touch the small number, the subscript, because that is part of the formula of your compound or your elements. In this case here, we have H2. That represents hydrogen molecule. A molecule is a substance that is made up of 2 or more atoms. It might be the same atom like we have in the case of hydrogen molecule here, in which we have 2 hydrogen atoms, or it might be of different atoms or different elements like we have in the case of H2O here. So right here we have 2 atoms of hydrogen and then one atom of oxygen. But we have this big 2 here at the front here, which indicates what? Which indicates that that 2 here is we're having 2 molecules of water molecules. Now, looking at this equation here, we have 4 hydrogen atoms altogether. How do I know that? I multiply this big 2 with the subscripts here. That gives me 4 atoms altogether. And let's count together. So we have 1, 2, 3, 4. For oxygen molecule, that is made up of just 2 oxygen atoms, and that is what we have here. Now, altogether, now we have what? The water molecule here. In the water molecule here, like I said, this big 2 here is for everything in this compound. So let's split it now. How many hydrogen do we have here? We have 4 hydrogen. That's this 2 multiplied by this 2. That is 4. So let's count 1, 2, 3, 4. So the hydrogen there is balanced. Same thing with the oxygen. This 2 here multiplied by 1 oxygen atom here. That makes it 2 oxygen atom. And so this equation here is completely balanced. Right now, let's look at some real examples and I'll guide you on how to do that. The equation that we have here is showing us 1 molecule of phenol. This is the formula of phenol. Everything here together, C6H5OH, reacting with sodium to give us sodium phenoxide plus hydrogen molecule. So we're going to start by listing out the elements in this compound on the reactant side all together. So having listed out the elements that we have in this reaction, we have carbon, hydrogen, oxygen, sodium on the reactant side. And if you look at the product side, we have the same element too. So our challenge now is how to balance it. So you count the number of each of the atoms that you have on the reactant side. So on my reactant side there, I have 6 atoms of carbon. So I'm going to put that there. So I have 6 of carbon atom. For hydrogen altogether, I have 5 atoms of hydrogen here, plus 1 atom of hydrogen there. That makes it 6 atoms of hydrogen altogether too. So I'm going to put that there. Now for oxygen, I have just 1 atom of oxygen there. And then for sodium, I have also 1 atom of sodium. Now I will go to the product side. So on my product side there, I'll look at it. How many carbon atoms do I have? I have just 6. So I'm going to write that there. So I have 6 carbon atoms there. Now, how many hydrogen do I have altogether? Remember that I shouldn't change the subscript. So I have 5 hydrogen atoms there. And then over here, I have 6. So I have 2 rather. So I'll split that out. I'll write it as 5 plus 2. That is 7. That shows that the equation is not balanced. Then now, what about for oxygen? For oxygen atom there, I have 1 atom of oxygen there. So I have 1 atom of oxygen there, and I'm going to put that here. Same thing for the sodium too. Also for the sodium, I have 1 atom of sodium. Now, taking a look at this, I can see that it's only the hydrogen atom that is not balanced. On my reactant side, I have 6 atoms of hydrogen, and then on the product side, I have 7 altogether. So what do I do? What if I have 1/2 to this? So if I put that as 1/2, that means that I'll be having just 1 atom of hydrogen there. Now, that means I need to change what I wrote here before. So I will change that to 1. So right now I have 1 here, altogether making it 6. And right now we can see that the equation is balanced because I have the same number of atoms on the reactants and on the product side. It's as simple as that. Now, someone might be wondering that can you use fractions to balance equation? Yes, it is allowed. In fact, you can even decide to use decimals to balance the equation. So I can decide to change this to 0.5. Now let's look at more examples. The second example we'll be looking at is for this reaction here. Reaction between sodium hydroxide and chloro-dioxide to give us water and sodium chlorate 4 and chlorate 5. As usual, what the first thing you need to do is to list out the elements on the reactant side, and then you list out the elements on the product side as well. Having listed out the atoms of the elements that we have on the reactant side, so we start counting each of them. Now, on my reactant side there, I have just 1 atom of sodium, so I'll put that there as 1. Now, how many oxygen do I have here? I have 1 atom of oxygen here, and then I have 2 here. So altogether, that is 3. Then I do the same thing for hydrogen. I have just 1 atom of hydrogen here. So I'm going to write that as 1. Now, what about chlorine? I just have 1 atom of chlorine here on my reactant side, and I also put that as 1. So we're okay with that of the reactant side. Now let's move to the product side. You do the same thing also. On my product side here, I have 2 atoms of sodium, 1, 2. So that's 2. So I'm going to write 2 there for the sodium. Now, what about the oxygen? Oxygen here, I have 1 plus these 2 atoms that I have here, that's 3, plus this 3, that is 6 altogether. So I have 6 atoms of oxygen there altogether. What about hydrogen? I have 2 atoms of hydrogen here, so I'm going to put that there as well. That is 2. Now for my chlorine here, I have 1 atom of chlorine here, and then another atom of chlorine here, altogether making it 2 atoms of chlorine. So this is what I have. Now looking at this, I can see that this equation is not balanced at all. Why? Because the number of atoms on the reactant side is not the same thing as what I have on the product side. And so I need to balance it. So we start by looking at that of the sodium. Take note, if you have an equation like this, you balance oxygen and hydrogen last. In fact, you balance hydrogen before oxygen. So oxygen is always balanced last, is the last atom you balance, because most of the time it falls in place on its own. So let's start. I have 1 atom of sodium here, and then on my product side, I have 2 atoms. So what do? I can multiply this by 2. So when I multiply that by 2, how do I do that? I decide to put a big 2 here at the front of that compound there. So now, like we said earlier before, whenever you put a big number or a number at the front of the compound here, that number is for the whole compound. So this 2 that I put here is for the whole of the sodium hydroxide. So in other words, that has changed this whole thing entirely. So right now I'm having 2 atoms of sodium there because I've multiplied that by 2. So that is 1 times 2, and that's giving me 2. So sodium is balanced. Take note, I said we're going to balance oxygen and hydrogen last. So let's move to chlorine. Chlorine here, I have 1 atom on my reactant side, and then here I have 2 on my product side. So what do? I also decide to multiply this by 2. So multiplying that by 2 gives me 2 atoms there. So I need to put the 2 here, which I used to multiply it. Remember that this 2 also that I wrote is for the whole compound here. So let's count for the remaining atoms. Now let's count the atoms that we now have all together. Now we have 2 atoms of sodium here, which is this. Now what about oxygen here? Oxygen here had increased. So right now in this compound here, I have 2 atoms of oxygen. And then over here, I'm having 4. That is 2. This 2 that I just wrote multiplied by the subscript of the oxygen here. Oxygen here on its own before was having 2 atoms. Now multiplied by the 2 that I used to multiply the whole compound. That is 4. So I'm having 4 there. So altogether, the number of oxygen atom here has increased to what? Has increased to 6. So I'm going to cancel out that 3 there, and I'm going to put 6 here. I hope that is clear. Let's do the same thing for hydrogen. Hydrogen here initially was 1, but right now it has changed to what? It has changed to 2. So hydrogen here, we now have 2 atoms of hydrogen there. So I'm going to cancel out this now, and I'm going to put 2 here. So let's count it all together and see if our equation is now balanced. So on my product side now, I have 2 atoms of sodium and I have 2 atoms of sodium on my product side. On my reactant side there, I have 6 atoms of oxygen and I have 6 atoms of oxygen on my product side. For hydrogen on the reactant side, I have 2 atoms, and on my product side, I have 2. For chlorine, I have 2 atoms on the reactant side, and on the product side also, I have 2. So that shows that this equation now is balanced. So we look at the last example for today, and that's the composition of cobalt, hydrated cobalt 2 nitrate. So this compound here is called hydrated cobalt 2 nitrate. Now, this 4 that we're seeing here represents 4 molecules of water of crystallization. The water of crystallization is embedded into the crystals of that salt. It doesn't mean that this substance was dissolved in water, no. But this water molecule that you're seeing here indicates that the water is embedded in the lattice of the crystal. So it is called water of crystallization. It's part of this whole formula. So how do we balance this equation? First, you need to check whether it's balanced or not. And how do we do that? We're going to list out the atoms that we have there. So we have cobalt here. So looking at it, we have just 1 atom of cobalt there. Now, what about nitrogen? Here we have 2 atoms of nitrogen. How do we know that? Because this is in brackets here. The nitrate ion is in brackets, and we have 2 outside it, that subscript. So that subscript is for everything in the bracket. So altogether, we have 2 atoms of nitrogen there. Now, what about for oxygen? So let's count. Same thing here, 3 times 2. That means here we have 6 oxygen atom plus 4 times 1. That is 10. So we have 6 plus 4. So altogether here we have 10 atoms of oxygen. Now what about hydrogen? 4 times 2. 4, the 4 here, we use it to multiply the 2 that is here, that is 8. So altogether here we have 8 atoms of hydrogen. Now let's do the same thing for the product side here. We have 1 atom of cobalt here. We have 1 atom of nitrogen here. Now let's count the oxygen all together. 1 plus 2, that's 3, plus this 2, that is 5, and plus this, that is 6. So altogether here we have 6 atoms of oxygen there. Now, what about hydrogen? We have just 2 atoms of hydrogen there. So looking at it, it's so glaring that this equation here is not balanced at all. So how do we now balance this equation? It's very easy. Now, you look at the atoms that are not balanced. Cobalt is balanced because we have 1 atoms on each side. Now, what about the nitrogen atom? Here on the reactant side, we have 2 atoms of nitrogen, but on the product side here, we have just 1. So what do? I multiply this by 2. So right now, I'm having 2 atoms of what? Of nitrogen there. So remember, I'm going to put the 2 here that I used to multiply it. I'll put it beside the nitrogen there. Okay, now let's go to balance hydrogen. Remember, I told you that you balance oxygen last. So hydrogen here, we have 8 on the reactant side. And on the product side here, we have just 2. So what do I do to make this 8? So I can decide to divide. 8 divided by 2 will give me 4. So I'll multiply this by 4. So that is 8. So this 4 that I used to multiply it there, I'm going to write it at the front of the hydrogen in the equation there. So I have that. Now let's count all together. Looking at this now, we now have oxygen. It's only oxygen that remains that is not balanced. We have 10 atoms of oxygen on the reactant side here, and then we have 6 on the product side there. So what do we do to balance that? It's very easy. So balancing this equation now, we focus on the what? on the product side here. We have 1 atom of oxygen here. Now here, remember that this 2 here has affected the whole compound here. So let's count the number of oxygen here again. So right now I have 2 multiplied by these 2 atoms that I have before. So right now there I have 4 atoms of oxygen there. I still have 1 here. And then all together here I have 4 atoms of oxygen. So here I have 2. So I have 4. So altogether I'm having 10 atoms of oxygen. But remember I told you that you can actually use fractions to balance your equation. So what if I change this to fraction and then I decide to put 1/2 here? So that makes this here. So that makes this here to become what? To become 1. So let's count all together for the oxygen now. So I have 4 plus 1 plus 4. Remember that we still have 1 atom of oxygen here. So I put that there. So let's count together. So this is 1 plus 4. That's 5 plus 1, 6 plus this, that's 10. So all together now, I have 1 plus 4 plus 1 plus 4. So altogether, I have 10 atoms of oxygen, and that makes the equation balanced. So that is how we balance this kind of equation here. So this will bring us to the end of today's lesson. I hope you enjoyed the video and you learned its balancing of chemical equation is very, very easy. You don't need to lose mark on it. So please remember to subscribe to my YouTube channel, like and share this video with your loved ones. See you in the next video. Bye for now.